Alright, here we're going to look at factoring binomials. Now, a binomial is going to be an expression that has two terms instead of one term like a monomial. When we factor these, they do factor a little bit differently than some of what we've looked at so far in this chapter. Just kind of a heads up for what this is going to look like. When you factor a binomial, you're going to have a set of parentheses, and out in front is going to be your GCF for the binomial for the two terms. And then I'll show you how we fill this in. So first thing we want to figure out is what is the greatest common factor between the two terms of our binomial. So we have a 6x and a 12. First thing I do is I look at the numbers. 6 and 12, what is the biggest number that fits into both a 6 and a 12? I know that 2 fits into both, so 2 is a common factor. 3 fits into both, so that's already a bigger one. I'm looking for greatest common factor, so 3 is a common factor. But is there a bigger common factor? And in this case, 6 is the greatest common factor. So we're going to put a 6 out front. And now you do want to look at the variables. You have an x in the first term. Do we have an x in the second term? Is x a common factor for both of the terms? And in this case, x is not in both terms, so all we have is 6 for our GCF. Alright, so we know that we're going to factor a GCF, the 6, out of both terms, out of the 6x and out of the 12. When you factor out from a term, factoring works just like division. So what I can do is I can go ahead and divide a 6 out of the 6x. Well, 6 divided by 6 is 1, leaving me with just that x. So whatever's left over for your two terms, and this plus sign is going to go in between them, whatever's left over is what we write in here. So the 6's cancel, leaving us with just the x. Now I'm going to factor a 6 out of the 12, which means let's divide out a 12. Factoring and dividing, kind of the same thing. 12 divided by 6, 2. So I'm going to put the 2 right there. So even though it looks kind of weird, this is what our answer is going to be. 6 parentheses x plus 2. It's kind of like distributing backwards. You know, if you were given this right here, and you'd say, oh yeah, I can distribute that. I know that 6 times x is 6x, and 6 times 2 is 12. So our answer looks like something that we should distribute, but we're not going to. We're going to leave it just like that. Alright, so when you're asked to factor a binomial, you have two terms with a plus or minus inside. You can go ahead and put your parentheses down first and think about what's the GCF that goes out front. So looking at the numbers, you have a 9 and a 15. What is the biggest number that fits into both 9 and 15? And in this case, I would say 3 fits into both. So a 3 goes out front. And now look at the variables. We've got an m on the right. Do we have an m in the second term? And since we do not, m is not part of our GCF. So we're going to factor a 3 out of both terms. So we're going to factor it out, which works like division. So 9 divided by 3 is 3, so that goes in our first spot, and the m sticks with that 3. Bring down your minus sign, and now 15 divided by 3 is 5. Now one thing that you can do to check to make sure, did I actually pick the GCF out front? Is 3 the greatest common factor? Look at the terms that you have inside your parentheses. You have a 3m and a 5. Do 3m and 5 have any common factors? If they do, then we know that we want something other than 3, but if they do not, like in this case, then we can feel good that we got the right GCF and that's factored correctly. Alright, moving on to the next one. Let me kind of illustrate that. How do you know if you got the GCF or not? So we're factoring a binomial. There's a plus sign in the middle. You can go ahead and put the plus sign in there if you want. GCF goes out front. So I look at these two and I might say, well, 2 is a common factor, and I think 2 is the biggest number that fits into both 4 and 8. So I've got the 2, but then I notice that both terms have an x. So how many x's do they have in common? Well, this one on the right only has one x, so that's the most x's that they could have in common. So our GCF is actually a 2x, or at least that's what we think the GCF is right now. So we can go ahead and factor a 2x out of both terms, and this will work like division also. When we do this, we can say, all right, well, 4 divided by 2 is 2. And then when you have an x squared over an x, two ways to approach this. You guys do know a property. Well, I'll just do it the long way. X times x on the top, there's your x squared, over x on the bottom. Those x's cancel each other out, leaves you with 1x. So you have a 2 with the x. Plus, now over here, 8 divided by 2 is 4, and your x's cancel out, so just a 4. So then we double check our work, and we say, well, did we get the GCF? Do you see how our two terms in here, you have a 2 and you have a 4? Do 2 and 4 have any common factors? And they do. 2 and 4, you can factor a 2 out of both of those. So that means that this 2 is not the GCF. So I don't want to leave this as my answer. Might be easiest just to start over, as much fun as that sounds. Say, all right, well, there's a number bigger than 2 that I can take out of 4 and an 8. And then we say, oh, 4 fits into both. So 4 is our GCF along with just that 1x that we came up with before, 4x. So factor a 4x out of both terms. 4 divided by 4 is 1. X squared over x leaves us with just an x. 8 divided by 4 is 2, and your x's cancel. So that's going to be our answer on this one. And now you can look at, you have an x and a 2. Do they have any common factors? Nope. So that's our final answer. All right, one more. I can go ahead and put the minus sign out front, GCF out front, or minus sign in the middle. So 12 and 15, what do they have? Common factors do they have? 3 is the only one I'm coming up with. Now we've got some variables to look at. This one's a little bit trickier. M cubed and an m. So how many m's do they have in common? They only have one m in common. And here, moving on to the n's, they both have an n. So that's part of our GCF. So our GCF is a 3mn. So we're going to go ahead and factor a 3mn out of both terms. So we're going to just kind of divide that out. 12 divided by 3, right there, is 4. M cubed over m. Again, if you want to think about it this way, over m. That m is going to cancel out the m on the bottom, leaving us with m times m, or m squared. And then n divided by n, those just cancel each other out. Minus 15 divided by 3 is 5. Your m's cancel and your n's cancel. So that's what we have for this one. And I know that one's a little bit trickier, but I just wanted to go ahead and show that in case you come across that.